Hello everybody, this is the first episode of my new programming blog. Hope you will enjoy it, please watch it till the end. In this episode I will present you a classic problem. I have this book here called Cracking the Coding Interview. This is a classic interview preparation book for Google or any big tech companies. I bought this book many years ago to interview for those mentioned big tech companies. In the end, I didn't make it, but whatever, in this book I found quite a lot of interesting problems. This is actually the 5th edition of the book. Let's open this book at page 430. So here is this classical problem. Write a function to swap a number in place that is without temporary variables. This isn't really a coding problem in my opinion, more like a theoretical computer science or mathematics riddle. However, the proposed solution is not correct. So yeah, it has problems. How many problems can you spot in the solution? Please stop this video and if you have the book open, try to find the problems in the solution. So let's start with the first proposed solution. Here it is, a simple mathematical trick. The first thing you may spot is that it might overflow or underflow. Is this a problem though? Well, mathematically speaking, you could try solving it with some random numbers using modular arithmetic. But what about programming? Well, it depends. For example, in C, some integer overflow causes undefined behavior. So the solution might not work well in practice. So there are other ways to solve this problem. For example, you could start with addition, subtraction, or you could use any other operations which is, if I'm corrective, bijective and invertible. So for example, multiplication, or you could use exponentiation or whatever you want. So you may guess what the next solution will be. So exclusive OR. But let's stop here for a second. The writer makes a mistake here. And the solution states that the benefit of this solution is that it works for more data types than just integers. It's not entirely correct. For example, in C, you could divide any data into 8-bit integers and do a pairwise swapping using addition or anything else. So let's get back to XORing. So XORing looks like a viable solution. However, it poses one problem. If the two pointers refer to the same memory location, the XOR swap corrupts the data. The value becomes 0. Avoiding pointers doesn't fully protect you. During inlining and aggressive optimization, the compiler may decide that the two variables are actually the same value, place them in the same register. If that happens, the XOR swap collapses and zeros the result. In C, you can prevent this aliasing problem by using the restrict keyword, which guarantees that pointers refer to distinct memory regions. In fact, Fortran has this behavior by default. Arrays are assumed non-aliasing. This is one reason Fortran dominated scientific computing for decades. It enabled extremely aggressive compile optimizations that C could not safely apply. Now let's look at what really happens under the hood. When we compile the XOR swap or the add sub swap into assembly, we see that the clever versions actually generate more instructions, more register dependencies and more ALU pressure, while the simple temp variable swap compiles to the shortest and fastest code. A quick cycle estimate, or simply letting an AI compare the assembly, shows that the XOR swap and the arithmetic swap are both slower. So yes, the whole thing was a waste of time. The compiler knew better all along. So what could be the good solution? Maybe there is an instruction for swapping in assembly. Well, I did a bit of research and it turns out yes, there is an instruction that does the swap for us. Here they are for Intel and for ARM. But there is yet another twist in the story. As it turns out, these are deprecated. Actually, the Intel one is deprecated and the ARM one is completely removed from the architecture. And I don't know why. I'm not an electrical engineer, so I can't answer this here. So as a closing thought, you could do tricks, interview questions, and mythical optimizations and learn them. But many times, the safest, fastest, and most readable and overall best solution is just leave it as it is. Just trust the compiler. By the way, I don't think preparing for these kind of interviews will make you a better developer. Don't fall into the trap I had fallen into. But if you want another riddle, you could try solving this problem in ternary computing, if you want to. Thank you very much for watching me. Please like, share and subscribe to my channel. Feel free to leave any comments below. But if I sucked, please tell me why did I suck and how to fix it. Thanks again.